Hey guys, this is Eric from Invensis Learning and I welcome you to our YouTube channel. In this tutorial session, we are going to learn everything about version control systems. Before starting with the agenda, let me give you a brief introduction to source code management. What is source code management? Source code is nothing but the code files of your application. But, why we need to manage source code? Let's take an example of an organization, which develops applications for its clients. Now, let's say this organization hires 3 developers for developing the code. But the organization already has a legacy code, so now the task to these 3 developers is to develop features using that legacy code file. In this scenario, developers need to work on their features and need to submit them back. Everything seems straightforward, right? Now, the company wants to follow monolithic architecture, which means all code should be in a single code file. This is where versioning comes into place. Whatever the changes made by the developer is not known to another developer. To avoid any mismatch of functionalities, source code management should be done to maintain the code consistency. This is a brief description of source code management. Now, let us see the agenda. We will begin our session with version control systems and their types, then we will discuss version control types in detail. After that, we will start with Git. What is Git? Post that, we will understand the lifecycle of Git. Then we will start with the installation of Git on different operating systems. Post that, we will see common Git commands that are used for versioning, followed by the demo on Git Commands. After that, we will understand the concept of branching in Git, and its conflicts, followed by a demo on Git branches and their usage. Post that, we will work on workflows followed in the industry and then followed by a case study, and finally, we will look at a task in version control using Git. Sounds interesting, right? So let's get started. Let's start with version control and tools used and their types. A version control system is a group of systems used to handle code files of various developers, so versions in real time can be handled using version control system. Now we will see the types of version control system. There are 3 major version control systems. They are local version control, centralized version control, distributed version control. Now, let us start with the types one by one in brief. Starting with local version control. Local version control is a local database located on your local computer, in which every file is stored as a separate patch. Everything seems fine, but the main problem with this is, everything stored in the local database. If something goes wrong, then the data will be lost. Now, we will see about centralized version control. The centralized version control system has a single server that contains all the file versions, which helps us to access files on the server, but here data is stored on the single server to give access across the team. If the server goes wrong, then data will be lost. Finally, we will see about distributed version control. The distributed version control is used to distribute the code between the local and remote servers, which helps the team to collaborate. Unlike other types of version control, here if the server fails, the team can send a copy of the version of the project in real time. Till now, we have seen the types of version control. Now, we will discuss Git. What is Git? Git is a free open source distributed version control system that is used to handle the source code more efficiently. GitHub is the web interface of Git tool, used to collaborate code between teams, and now, we will see some trivia about Git. Git is an established and continuously maintained open source project founded in 2005 by Linus Torvalds, the well-known author of the Linux operating system kernel. Git is used for version control in a startling number of software projects, both commercial and open source. Git is a version control system for tracking changes in computer files and coordinating work on those files among multiple people in the team. Till now, we have seen the history of the Git tool. Now, we will discuss Git Lifecycle. Git Lifecycle consists of 3 stages. Those are working directory, staging area, commit. Here, working directory is the place where project files are stored in the local disk, and the staging area is the place where the changes in the files are tracked by Git. Finally, the commit phase is responsible for saving the files in the Git repository. Till now, we have discussed on Git Lifecycle. Now we will understand how Git Lifecycle works. Here as per the slide, we can see the version control using Git starts with the project workspace where the code files will be created, and then the next phase is adding the code files to the working directory where Git is initialized. Once the changes are finished, files will be added to the staging area, and this is the place where Git tracks all the changes, and after adding to staging area we can commit or save the changes in the repository using commit command, and then the next phase to share the code files among team members. And in order to do so we will push the changes to GitHub, and this is a web interface of Git used to share the code and maintain its versions among team members. I hope this helps how a file in Git handles the version of files. Now we will further see how this Git works. Here, we will try to see how a code file is pointed. After adding the changes to the code file in the working directory, changes will be staged and tracked by Git for version control. Similarly, a new committed will be allocated after each commit. Hence committed is used to retrieve the version of data. All these commits are restricted to an area called branch, and the pointer to the latest commit is known as head. This is all about how Git works in an overview, so let us start with the installation of Git. Here, Git is compatible with all type of operating systems. Now in this tutorial, we will understand the top operating systems used in the industry. Those are Windows, Linux, Mac OS. Starting with Git Windows, in the Windows operating system, we will use the Git bash terminal for Git, and for installing refer to the links given in the description. And installation in Windows is simple. You need to download the package and execute it that will install the Git bash terminal in your system. Now we will try to understand how we can install in other operating systems. Git installation on Linux systems. The easiest way to install Git is to run the package from the package manager of your Linux distribution. For Ubuntu, the command is apt-get install Git. And for CentOS is yum install Git. Now we will see for Mac operating system. In the Mac operating system, you can either use brew or Xcode for installing Git, but the easiest way to install is brew install Git. All you need to do is open the terminal and execute the brew command, and that will help you to install Git in Mac. Till now, we have seen the installations in various operating systems. Now, we will see what is GitHub and will understand how to create an account in GitHub. Here GitHub is the web interface of the Git tool, which is used for versioning. GitHub is the common platform shared among the team and maintains the source code management. You can create an account in github.com. Account creation is similar to the mail creation process. You need to sign up with a username and Gmail for a GitHub account. Till now, we tried to understand the Git and how it works. Now, we will learn about the commands used for version control. Starting with the initializing command. Git init. Git init command is used to initialize the Git repository in the local project repository. Here in the screenshot, we can see that Git is initialized in an empty repository, and this is how we can convert our project directory to a working directory. Now, we will discuss on status command. Git status command is used to check the status of the file in the working directory. Here in the screenshot it clearly shows that there are some files created and those are not tracked by Git, thus, you can check the status of Git files. Now, as per the previous command, Git status shows that there are files that are untracked, and to track those changes we will use the git add command. Git add command is used to stage the files and track the changes made in the files. You can add all files using a dot. Once we run this git add command, the files will be added to the staging area. In the previous slide, we have seen about adding files to the staging area. Here in this slide we will see how those changes are saved in the local repository. Git commit command is used to save the tracked file in the local repository. Once we run the commit command, it is mandatory to run with a message tag using -m. So far, we have seen the commit command, and now we will understand how the GitHub repository is added to your local working directory. For this, we will use git remote add command. Git remote add command is used to add the GitHub repository to your local system. Generally, it is called the origin. After adding the remote repository, to push the changes into it, we will use the git push command, and this is used to push the commits to the remote repository. It will prompt for username and password. Here you need to provide your username and password of your GitHub account where the remote repository is present. After pushing the changes to the remote repository, you can also check the log of Git and its commits. For that you will use the git log command. Git log command is used for the logs of commits that occurred in the working directory. Now, we will see a command that helps us to revert any changes that are made accidentally. To change the commits we will use the git revert command. Git revert command is used to revert the commit changes in the working directory. As the screenshot shows that, once we run the revert command, then it will automatically remove the commits. This is one of the important commands in Git. If you are working with a repository that consists of legacy code or the other developer's code. Now, in this case, the git clone command gets into handy. Git clone command is used to clone the repository from GitHub. Git commands will be incomplete without the branch command, because this command is helpful or responsible for creating a copy of code and gives it to the developer so that the changes are not made on the master branch directly, and after verification, we can get those changes updated. These are the few Git commands that we have seen along with screenshots. Here we will see the commands and their execution. Till now, we have discussed Git commands and their usage. Now, let us start with our demo on common Git commands. We will see about GitHub, and then we will see how to install Git. In order to access GitHub, which is a web interface of GT tool, for opening it, navigate to the browser and search for github.com. Here this is my GitHub account. Let me log out first and show you how it looks like when you open GitHub. Once after clicking on the sign out, it redirects to our landing page, and if you are new to GitHub you can create an account in it using your mail-in and username. And if you have an account in GitHub you can use the same, and this is web interface, but this is not the tool that we have discussed so far. Now we will see how to download Git. Click on the new tab, and search for download Git and click on the first link, which redirects to the Git documentation where the packages are available for different operating systems like Windows, Linux, Mac OS. Here my machine is a Windows machine, so today we will be working on Git for Windows. Once click on Windows, the package will be downloaded automatically and you can install Git by just running the package. At the same time, you can also download the Windows package based on the number of bits as per your laptop configuration. In my system Git is installed already, so let me open it, and in Windows, we will have Git bash for using Git tool. A terminal is opened and this is our Git bash. Now, we will start with entering into the download folder, using cd command, and once we execute it we will be inside downloads folder, and for this tutorial, I am creating a separate folder called Git, but it throws an error saying that Git directory is present already, so let us change the name to Git Tutorial. After creating the folder, we will enter it using the cd command. An ls command shows the files present in the directory. As I create a new folder it is empty. If you want to check the location use the pwd command and that will show the current directory path. Now we are in the Git tutorial directory. Let me clear the screen using the clear command. And the git status command will show the status of all files in the download folder, but we are using Git tutorial directory as our working directory, so let us initiate the Git in this directory. So let me clear the screen and initiate Git using git init, which will initialize Git in the working directory. Now for verifying the Git we will check the Git folder using ls command. Now, Git is initiated and ready to start working on Git commands, and Git is a version control tool, so in order to handle the versions first we need the file. So let us create a file using nano editor and create a file with some pseudo sentence and save the file, and now the file is created, and before working on Git commands, we will check the Git status. Once we run Git status, there we can see a file under the untracked section, which means the file is created but the changes are not tracked by Git. So in order to track the changes, we need to add the file to the staging area. For adding a file to the staging area, we need to run git add command. Here this throws us a warning that a file will be added in the working directory. So here, in order to ignore this warning, we need to run the command again. So let's run add command again, and this time the command executed without any warnings. Now let me clear the screen and check the status of Git. Now this will show there is no file in untracked section, and it shows no commit. So let us commit the changes using the commit command, with a commit message as first commit. After executing the command the file will be committed, and from now we can retrieve the commit. Now, we will check the log of Git, using git log command where the output shows the details of committed. This is how we can check the logs. Now, let me clear the screen, and we will test it again using a different file. So let us create a new file using nano editor, and next, we will check the status of the file. Where the new file will be under the untracked section, so now, we will add the file to the staging area using git add. And we can add the files with the dot. Again, to ignore the warning we will use the git add command again and commit it using the git commit command with the commit message as the second commit. This time if we check the log we can see the second commit. Now, let me clear the screen. We will see the log more understandable way. We can use pretty inside the log command syntax, that will display as a graph, and now the head is pointing to master because we don't have multiple branches, so let us see how to create them. For creating the branch, the command is the git branch. Here in this I am using the git branch command to create feature branches. After executing the branch command, you can check the branches with the same command but without the branch name. This helps us to check the branches present. With this Git branch command, we have created the branches, and in order to enter the branch the command used is checkout. So let us run this checkout command. Now, once we run this we will enter into the respective branch. And now, if we run the branch command then we can see the branches but the star points to the feature branch, and thus we can confirm that we are in this branch, and once we do an ls command then we can see the files same as master. These are the major commands used in Git for version control, so let us see what other commands are left. Now, these are the major commands, and we will now understand how to push those changes to GitHub. So let us go to the browser and browse for GitHub, and sign in with the credentials of GitHub. And after clicking on sign in it will redirect to the GitHub landing page. So let's start with creating the new repository. For creating it you need to click on the plus icon where you can choose a new repository. And give a unique name for the repository. So let's start with Git Tutorial, but it is already used for my R&D. So let us use a different name and then we can create a new repository. Now we have successfully created a new empty repository. And copy the URL. This is used for adding to the remote repository. Now, we will add this URL as a remote repository, so let us jump to the git bash and run the remote origin command, and this will add the repository as a remote repository. After adding the remote repository in now, we will push the changes to GitHub and it will open a GitHub credential page. So here we need to give a username and password, and it failed because I have a different credential, so we need to add the credentials from OpenSSH and use the credentials again, and that will help you to push the changes to the GitHub repository. After that, if we refresh the changes in the repository you can see the changes inside the repository. And then git clone command is used to clone the repository to our local system, so that we can work on it. Now we will make some commits and how it looks like using git log. Here are the commands used in the demo, and you can get those commands from the description below. As a part of Git Commands, we have discussed a bit on Git branching. Now we will try to understand the concept of branching in detail. In simple terms, Git branches are effectively a pointer to a snapshot of your changes. If a developer is assigned a feature then a branch will be created, which has a snapshot of the previous commit. Let us understand with an example. Let us say we have some code for our application, and after the second commit we create a branch, then the commit changes are copied into the branch where we have all the data related to previous work and given it to the developer, where he or she works on the feature and creates further commits, and then we can update those changes back to master so that the changes made by developers does not affect our initial application code. It creates the copy to work on the features. This is one of the most used examples of branching. We have discussed Git branching with an example where the code is given to the developer for work. Now, we will see how to merge the updated changes to the master branch. So let's start with merging branches. In each organization, there are multiple developers who work on multiple features. After each feature, it will be merged with the legacy code and distribute among the developers in the team. Hence, merging is important to maintain consistency among code files. The master branch is responsible for all updates in the production. Now, we got an idea of why we need merging. Now we will see an example, how the branches are picking the updates. Let us say we have a master branch where our organization's legacy code or initial code is present. Now, the company hires 2 developers for creating 2 features. So here first, it creates a branch for feature 1 which is developed by the developer 1. He worked on the feature and committed the changes in the branch. Now his work of developing a feature is finished, but as an organization, it needs to develop the second feature as well. So, for that we will merge the feature 1 branch with master. Once the merging takes place then the master branch is updated with feature 1, and if we create a branch now after merging then the new branch will also consist of feature 1. This is how we can merge team members' work with all other team members. I hope this example clears your understanding of merging branches. Now we will see about Git Merge. Git Merge. If you want the changes made in branches you can merge them to the master branch. Here merge can be done only on the remote branch and it creates a new commit to merge the changes. Now, let us understand this Git merge with an example. Here is a developer who is working on a feature and finished with the features. Now we will see how changes are updated to master branch. Let's say we have created a new branch after the first commit, which means the branch created has all changes of commit 1 and after that. If we made the changes with the code in the feature branch and commit it, then these changes in a feature branch is not known to my master branch, and in order to update it we will use the merge command, and that helps us to update the change in master branch. If we see the image, it demonstrates the same, where the changes from the feature branch is merged with the master branch and there it forms a new commit. Till now, we have seen how this merging works. Now we will see the syntax to achieve this merging. Git merge command is used for merging the changes, and the syntax for merging is git merge name of source branch. Here the screenshots define how the changes are added after executing the merge command. So far, we have seen the git merge command. Now we will understand rebase, and how does rebase works? Along with syntax. If the changes are present in the local branch and update to the remote branch, then rebase is used. Here the master changes will be added to the feature branch, and this branch is detached from the previous commit and attached to the master with a new commit. Now let us understand with an example. Rebase is used only with the local branch. For example, here is a developer who is working on a feature branch in his or her local system and finished with the features. Now we will see how changes are updated to the master branch. First, after getting the files from the GitHub to our local system, and then we can work on the changes locally, and these are not tracked by the remote branch. In that case, we will modify the head to the local branch. Once the developer rebases the changes to the master branch, then the local branch is merged with the changes to the master. By the name rebase suggests that changing the base, here this will change the head pointed to the local branch so that the changes are added to the master branch. I hope this helps to understand rebase and its working. Now, we will understand the syntax of rebasing. Here the syntax of rebasing is git rebase local branch name. In the below screenshot, you can see how the rebase command looks like in its execution. Till now, everything seems normal in handling the versions, but these concepts are with respect to multiple files. But let's say all these changes are made to a single file. There occurs the conflict. We will now discuss conflicts in merging the changes. The main reason for a merge conflict is when the changes made in other branches are not known to the branch. Merge conflict needs to be resolved manually with the help of the merge tool, but the best way is to avoid the conflict. To avoid it, we need to make sure that the branch is updated with all the changes while merging. Now, we will understand the concept of conflict with an example. Merge conflict occurs if the file is modified by another developer and the changes are unknown to your file, then merge conflict occurs. Let's say there are two developers given task to update the existing functionality. Suppose if the first developer finishes the changes and merge them with the master, if the second developer takes some more time to update his functionality, while the second developer tries to merge the changes, then there occurs conflict because he does not have the changes made by the first developer. Merge conflict will occur at the time of merging and rebasing the branches where the changes are unknown. Here the image shows the commits made to a branch. While the second developer merges, then the conflict raises, and to resolve this we will use the merge tool, in which is used to display the changes, and we can review them and commit it for resolving this conflict. Now we will see how a merge tool looks like and the syntax for using merge tool. The syntax is simple, git merge tool, and you can also use additional tags for opening in the editor. Merge tool will show the file history, and that helps to identify the dependency for the conflict and resolve it. Till now, we have seen the theory part of merge conflict and branches, so now, we will see a sample demo on how a conflict is resolved. Welcome to this demo. Here we will try to see the merging of branches and resolving the conflicts. So let us start with creating the files with nano editors. So open a file and some content to it and save it. After adding the file, we will add this file to the staging area. And then commit the changes, using the git commit. And then we can check the logs using the log command, and you can see the logs using the graph. This shows the commits that we have made in the working directory. After adding those commits in branches, we will check out to the master branch and run an ls command. Here this shows only 2 files but not the latest commit changes. This is because we are in the master branch but the commit is made at feature 2 branch, so now, we will merge the changes to the master using merge command. After executing the merge command, the changes will be added to the master branch. Now, clear the screen and we'll check the git log command to check the changes. Now, logs show the commit from the feature branch. And at the same time, we can merge feature 2 from the master branch so that the changes are added to the master branch. Now, it opens a new commit file and it shows the merging of the feature 2 branch. Once after saving the file, the changes will be committed. And the git log here defines commit using graph, and there it shows the commit from feature branches, and finally, it points head to master branch. Now, we will start with conflicts, how it occurs and how to resolve it. So let us start with a new file with a name conflict file and create a legacy code in which is nothing but a simple pseudocode file with the main function and save it. After that, we can see the changes using the cat command. And then we can add this file to the staging area and commit it with the commit message as legacy code. Once we do an ls command, then we can see the file that we have saved. Now for generating the conflict, you need to start with creating new branches, and there the changes can be done to the same file leads to conflict, so let us start with the creating branches. Now we will run the branch command for the developer branches. Here I have created 2 branches, which have the legacy code copied to branches, so now, we will add the changes in the master branch so that these changes will be unknown to the branches. Open the text file with Nano Editor and add the pseudocode to the same file. Earlier in the demos, we have seen things by changing the contents of different files. Now, we will add some lines of code where this will generate a commit. So now, the file is added with the changes, and before going to branches we will track the file using the git add command and then commit with a message. Now the commit is made successfully from the master. Now, if we check the log, then a new commit will be added with the commit message. This shows the commit is made, and the head is pointed to master. Now, we will check out to dev1 branch and do an ls command, then we can see the file called conflict.txt. But, here the file does not has the changes added, so let us see it. Now, this cat command shows the contents of the file, but there is no secure patch code because it is added after the branch is created. Now, let us assume that this branch is given to a developer for adding features where the developer might not know about the update done in master, and he will start with his work in this branch and update. Here this is the first step to generate a merge conflict. In this demo, we will stimulate a conflict and try to resolve it. Now, we will discuss the agenda of what we do from now. First, we will update both the developer branches will be updated with new features with pseudocodes. After adding those changes to branches, we will try to merge the changes back to the master branch, and meanwhile, if we encounter any conflicts, then we will try to resolve it, and all the changes are done only to the conflict file. Now, I hope this clears the things that we are working on a single file without the updated changes. Starting with the feature update of dev1 branch by opening the conflict file with Nano Editor and add pseudo contents in it and save the file. Following that, add the file to the staging area and commit it. Now, this will create additional change, and that is present only in the dev1 branch. Now, we will start with the other branch dev2 and add the sudo contents to the conflict file, and this file in dev2 does not consist of the changes updated in both the master and dev1 branch. Here we will add the contents and then send the file to the staging area and then commit the changes with a commit message of feature 2 added. Now, we have added the features in their branches respectively. Before merging to master, we will check out the logs made in the dev2 branch. Where this shows the head is pointed to the dev2 branch with the latest commit. Now, we will check out to master branch, and before merging, check the contents of the conflict file using cat command, which shows the content with only the secure patch and legacy code. Now, if we try to merge the master branch, then due to this secure patch we will get a conflict, and then we will see how to resolve it. First, let us check out to dev1 branch and then do an ls, which shows us the conflict file, and if I run this merge command, this will merge the changes from the master, but here due to the unknown commit in the master branch, it throws a conflict, as it clearly shows that merge conflict occurs. So we need to resolve it manually and commit the changes. For resolving the merge conflict, we will open the merge tool with the vi editor. Once execution, it opens a new console where we can see all the changes. On the left-hand side we can see the dev1 branch where we have feature 1, and on the left-hand side we have the secure patch, which is the master branch data. And in the center we have the common data known to both branches, which is the legacy code. So to resolve the conflict, type I on your keyboard. That will allow you to enter data below, in which you need to update your code in such a way that the feature 1 and secure patch is present. For that, you need to delete the additional information as head and the branch names and make the code to the desired format and then save it. For saving it, you need to use the escape button followed by $WQ. Once saved, you will see the different screens, but as we have already made the changes, we will just exit using $Q. Now, I have reached back to my terminal screen, and now we will add the changes and commit it, but while doing that you will find a new file present that has an extension of original. This file consists of the history of conflict, and that helps to understand the changes. All seems fine, but to add those changes to this branch we need to commit, so let's add all files to the staging area and commit the changes. And once we check the logs after commit, we will see the new commit with name updated secure patch. Now, we will do the same to dev2. Now, we have done the updates the same as dev1 branch in dev2, but this is not the final change, because we done all the updates in developer branches and not in the master branch. So now, our final step of this demo is to update the master branch with all features, and if I try to merge the first branch, it will merge automatically with the master branch, because a secure patch is updated in that branch. Now we have merged the dev1 branch to master that has feature 1 updated, and now, master branch has feature 1 added, but this feature 1 is unknown to dev2 branch. If we try to merge the second branch, then the conflict occurs again, which need to be resolved manually with mergetool. Now, we can see the conflict while merging, and we need to resolve the conflict using mergetool. After deleting all the conflict changes, we will commit it, and this time we will see another file added, and this is because the new conflict and conflict will always create an original file that has the history of the changes. Thus, if we require any changes to be done, then we can easily retrieve the data. Now, we will see the log of commits, and that helps us to understand how the changes are done. Here is the graph of logs, so we will try to understand them from bottom to up. Where it all starts with initial commits, till the fourth commit we have used in the previous demo, and then we have seen merging of a branch, and in this demo, we have created the conflicts and resolve it. So starting with a legacy code commit, we have created a new file and then created 2 branches, those are dev1 and dev2, and after that, we have made the changes in the legacy code. And created a commit in which a patch is added, and then we have started with the features added, and then we came to know that the security patch is added and we need to update the feature branches. So for updating it, we will merge the master to both feature branches, and then there occur the conflicts which we had resolved using mergetool, and after updating both branches we will merge back the changes to master and resolve conflict in master. Thus, we create an architecture that helps developers to update those changes if there is a conflict. This is the only option to resolve the conflict if occurs, but companies or developers will try to avoid conflicts by updating the changes regularly. But if a conflict occurs, mergetool is the only option we have to resolve in Git. I hope this demo clears your concept of merging and its conflicts. I hope this demo helps you to understand completely on branching. Now we will see the workflows followed in Git. There are 3 types of workflows in Git, and they are: centralized workflow, feature branching, Git flow workflow. So let us understand these workflows in detail. Centralized Git workflow. In this workflow, all changes are directly made on the master, and finally merged on the remote master. Once work is finished and before pushing changes, the master is rebased with the remote commits, which results in clean and linear history. By working directly with the central repository may lead to the conflict of version control. To overcome this problem, we have a workflow called feature branching, so let's understand about feature branching. Here in feature branching we will use the branching concept and create a branch for individual and finally merge to the master after modifying the changes. The number of branches is dependent on the development plan, and here there is a drawback with this workflow, which is that changes done in feature is merged directly to master, which increase the risk of having conflicts, and to overcome this problem we have a workflow called Git Flow Workflow. Git Flow Workflow is an extension to feature branching, and the only main difference is that there will be an intermediate branch and verify the changes, and once verified then we will merge that intermediate branch to master, and the unverified changes are checked under the intermediate branch to avoid conflicts. These are the workflows of Git. Now, we will discuss the webhook in GitHub. Webhooks allow you to build or set up integrations, such as GitHub apps or OAuth apps, which subscribe to certain events on github.com. When one of those events is triggered, we'll send an HTTP post payload to the webhook's configured URL. Webhooks can be used to update an external issue tracker, initiate continuous integration builds, update a backup mirror, or even deploy to your production server. This is all about webhook. Now, let us discuss forking and why is it useful? Forking in Git is used to copy the contents of others' repositories to your GitHub account so that you can work on the code and you can contribute to the code. If you are working on other open source projects, then forking helps you to get the code into your GitHub account. Now, we will see how forking of a repository works. For forking, you need to visit the repository that you want to work and click on the fork button to get the source code from that repository. Refer to the attached screenshot, that helps you to fork the repository. These are the core components of Git used in the industry, and now we will see a case study in Git. Implementing workflow to an organization that follows monolithic architecture with multiple developers. Suggest a workflow. Demonstrate the workflow by implementing it using pseudocodes. This is the problem statement where they are asking for us to suggest the workflow. So we will further elaborate to understand what they are asking us in the case study. Here in the slide, we made it simple so that everyone can understand. Here in this case study, the organization is using monolithic architecture, which means there is only one single code file. So here we need to suggest a workflow that avoids conflicts, and as we have discussed in this tutorial earlier, and you need to update the master branch with changes and push to GitHub repository. This is all about the case study in Git. As we have seen the demos over Git, I'm going to give a task for you, where you need to implement the case study. As mentioned, try to test your understanding by implementing the case study and submit the GitHub repository URL in the comment section, so that we can check and let you know with the feedback. Before concluding this session, we will understand the usage of Git in DevOps. Git is a version control tool used for source code management in any organization, and the DevOps lifecycle starts with source code, and Git plays an important role in coordinating the code file version among developers. Using GitHub, team coordination can be achieved with the latest code files, and we can automate the source code versions using workflows. And to learn more about the concepts of DevOps and its tools, check out the courses and certifications offered by Invensis Learning. And for regular updates on videos, do subscribe to our YouTube channel and click on the bell icon for regular updates.